So what is a schematic? It's a symbolic representation of an electrical circuit, and you use it to define how the parts or components in your circuit are connected to each other. Oftentimes people will do it first on a piece of paper and then they convert it to their computer. Other times they'll do it straight from their computer. So the advantage of getting it on your computer is that you can then test the circuit with a simulation program like SPICE, and it's very easy to convert it to a printed circuit board as well. So I've downloaded and installed Diptrace, and Diptrace comes with a couple different programs to help you along the way. The program we're going to use to build schematics is called Schematic, and the way you do that is just download it, install it, double click on Schematic, and it'll start running. On the top here you see a list of libraries, and each of these libraries contain several components that are related to each other. For instance, the diode library contains a bunch of different diodes, and the Altera library contains a bunch of Altera components. I'm just going to show you how to build a really simple circuit, just an LED that stays on all the time, and it consists of a voltage regulator, a couple capacitors, an LED, a resistor, and that's it. So let's start, and we'll grab the voltage regulator first. In Diptrace, voltage regulators are organized by their manufacturer, and we'll grab an ST voltage regulator. So we scroll to the right till we find ST. This is the ST library on the left, and the one we'll use is an L7805, and you can just use this search bar to find it. And you'll notice on the bottom left here, this is the footprint. So if or when you convert this to a printed circuit board, this is the shapes and the pins that will go on that circuit board. So to put the 7805 on my schematic, I click on it here. I move over to this big black area. This is where we'll draw the schematic, and I click again. If I need to place another voltage regulator, I can just left click, or if I'm done, I can exit the part placement mode by right clicking. So that's my voltage regulator. You see pin 1 is a voltage input. We'll connect that to a battery. This is pin 3, it's connected to ground. And pin 2 is the voltage output. We'll connect that to a resistor and then to our LED. Second, let's grab the battery. And the battery is in the discrete schematic library right here with a couple other things. And there it is, battery. Now, in Diptrace, some components have a related footprint, but not all of them do. And the battery does not have a related footprint because there are a couple different ways you could connect a battery. So we drop it down, we click on it, drop it here. And then if we right-click on the battery we just set down, we can go to Properties, and we can attach the footprint or the pattern that we want to use. For this battery, we're just going to use a jumper, right? We'll use a little battery box to connect. So this jumper is just going to be 2 pins that will connect to a battery box. So pin 1 of the battery, we click right here. The negative will go to this square, and the positive from the battery box will go to this pin right there. Right click OK, and click OK. So now our battery is all connected, and it has a related pattern. Use spacebar to rotate the pattern or the part on your schematic. You can do it like that. Now on one side of the battery is the negative, and that connects to the ground right here, and the other side is the positive, and that connects right here. So now our battery is connected to the voltage regulator. It isn't a requirement, but it's nice to make this easy to read. The computer understands how everything is connected, whether it looks nice or not, but it helps you in troubleshooting if you have any problems if things are fairly easy to read. Another thing, on most voltage regulators, the data sheets require a input bypass cap and an output bypass cap. So let's grab those and set them down right now. The caps are in the discretes library, and there's the basic capacitor, and you can see the footprint. It's just 2 holes, and they're spaced at 100 mils, or 1/10 of an inch. And we can rotate them like that. There's one. There's two, and I'm done placing those caps, so I right click and I'm done. So this cap will connect right here, and the other side of the cap will connect to ground right here. Same thing here. This will go right here, and this guy will go right here. So we have our voltage regulator, power source, and some bypass caps for the voltage regulator. The next thing we want is another component in the discrete library. It is a resistor, and we just scroll down until we find the resistor we want. There are a couple of resistors. You see these 1200, 1300. That just defines the mils, or 1/100th of an inch between each of the pins. The basic resistor, the one that you usually use, is a 1/4 watt, and it's spaced at 300 mils. So it's RES right there. Drop that in, and then the last thing we need is our LED. I'll drop that in. So then the negative end, the cathode of the LED, connects to ground, which is right here. And the positive end, it'll first go through the resistor to limit the amount of current that flows through that LED. And the resistor will be connected to the voltage output of the voltage regulator. And we'll just space that to make it look nice. Grab those two like that. And there you go. That's a very basic circuit. Hold on for the part 2, and I'll show you how to convert this to a printed circuit board, and then we'll go from there.